Welcome to all my dear students. Myself Nandini S, working as a lecturer in Mechanical Engineering Program, SJ Government Polytechnic, Bengaluru, Department of Collegiate and Technical Education. We are in session 6 of Unit 1, Measuring Instruments. So in the last session, we discussed about errors in measurement systems. So error is defined as the difference between true value and result. So coming to the types of errors in measurement system, so we have mainly three types: systematic errors or fixed errors, random errors or accidental errors, and illegitimate errors. So systematic errors will have definite magnitude and direction, okay, and it will appear regularly when the measurements are done. So we need to find the systematic errors with the help of calibration. So we need to calibrate measuring instruments in the regular time periods. Okay. So in systematic errors, so we have human error, environmental errors, stylus pressure, instrument errors, okay, etc. And also we discussed in detail. So next, let us move on to random errors or accidental errors. So errors that occur randomly, that is unpredictable, and it is of unknown magnitude, are called random errors. So these errors occur randomly. It is unpredictable. We cannot say. Okay. And this type of error are normally of limited time duration. But when we compare random errors with systematic error will appear regularly, okay, repetitively. When you make measurements, so it will be of fixed magnitude, so it will appear regularly. Okay. See, random or accidental errors. So mechanical vibration, instrument reproducibility, hysteresis in elastic members, friction in instrument movement, backlash in the movement, especially backlash will occur in gears, and a parallax error between pointer and scale, and observer's skill or human skill, and errors from environmental variations. So these comes under random or accidental errors. See, mechanical vibration. We know in mechanical instruments or in some machineries we have some foundation, right? Foundation, and there will be some moving elements. If there is vibrations, so we need to eliminate that vibrations. Okay. Due to mechanical vibration, it may give some errors. So next, instrument reproducibility. Instrument reproducibility means, so it is the ability of an instrument to reproduce the output readings when the same input is applied to it repeatedly under the same conditions. Okay, so the same conditions means the conditions are the same observer, the same instrument, the same procedure, the same place maintained with good ambient conditions. So these are the conditions. So when we make measurements in the same conditions over a long time duration, if the instrument gives the same output readings when the same input is applied, so then it is known as instrument reproducibility. Okay. So the instrument should give the same output when the same input is applied under same conditions. The conditions are the same person should make the measurements in the same place, by using the same instrument and by the same measurement procedure. So then only we can get the results, the same results. So this is for long duration of time. When I do the measurement now and when I repeat the same measurement after many hours or day after tomorrow, like that. So the instrument should give the same output readings. So then we say the instrument has the reproducibility. Okay. So if the instrument has no reproducibility, so this is also one of the random error. And next, hysteresis in elastic members. So this concept is explained in the systematic errors. So elastic members means, see, mainly the hysteresis occur in moving elements. Okay, moving elements like gears, when there are links, pointer and scale, cam followers, so etc. So here the hysteresis in elastic members means like when there are spring elements, okay. So due to the extension or retraction of those elastic members, there will be some hysteresis, and hysteresis also the one cause for random error. So sometimes it will be there, sometimes it won't be there. It is not the fixed type of error. It is accidental. We cannot predict the error. It is unpredictable. So next, friction in instrument movement. If there is some friction, as we know, in mechanical measuring instruments, there will be more moving parts. When there is moving of the parts, there will be friction. And when we use the instruments regularly, there will be some wear and tear. Okay, so like that. So this is also the random error, comes under random error. Backlash in the movement. See, this backlash error occurs in the gears. Okay, and I think you people have observed when we use pointer and scale arrangements or pointer and scale display unit in the measurement systems, some measuring devices. See, sometimes the pointer will be deflecting like this. Okay, it won't stand at the particular reading. So that is the backlash error, and that pointer backlash or a pointer deflection, that is due to some gear arrangements. Okay, when there is some um, problem in the gear movements, so there will be the backlash errors. So next, coming to parallax error between pointer and scale. So see, this is the best example for parallax error. Here we have one container filled with some fluid or some water. The person should observe the reading with the help of this scale. Okay, and the person observes normal to this scale, so he will get the exact reading, the true value he will get. And the person sees the scale from in this direction, there will be some error, and from this direction also he may get some errors. So always the observer should observe the scale normally. Okay, so see, no parallax error. So this is with parallax error, and this is also with parallax error. ಸೊ ಕರೆಕ್ಟಾಗಿ ಸ್ಟ್ರೈಟಾಗಿ ಈ ಥರ ನೋಡಿದಾಗ ಸ್ಕೇಲ್ ಹೀಗಿದೆ ನಿಮಗೆ ಕಂಟೈನರ್ ಮೇಲೆ, ಈ ಕಡೆಯಿಂದ ನಾರ್ಮಲ್ ಆಗಿ ಅಂದರೆ ರೈಟ್ ಆ್ಯಂಗಲಲ್ಲಿ ನೋಡಿದಾಗ ನಿಮಗೆ ಕರೆಕ್ಟಾಗಿ ಆ ವಾಟರ್ ಲೆವೆಲ್ ಎಲ್ಲಿಗಿದೆ ಅಂತ ನಿಮಗೆ ಗೊತ್ತಾಗುತ್ತೆ. ಸೊ ಸ್ವಲ್ಪ ಮೇಲಿಂದ ನೋಡಿದ್ರೆ ನಿಮ್ಗೆ ಏನು ಕಾಣಿಸ್ಬೋದು, ಫಾರ್ ಎಕ್ಸಾಂಪಲ್ ಇದು 1 2 3 4 ಅಂತ ತಿಳ್ಕೊಳ್ಳಿ. ಓಕೆ, 4 ಎಷ್ಟು ಇರುತ್ತೆ, 4 ಸೆಂಟಿಮೀಟರ್ ಎಷ್ಟು ಇರುತ್ತೆ ಇದು. ಸೊ ನಿಮಗೆ ಈಗ 4 ಸೊ ಎಷ್ಟು 4.2 ಅಂತ ತಿಳ್ಕೊಳ್ಳೋಣ. ಓಕೆ, ಸೊ 4.1 2 3 4.3 ಅಂತ ತಿಳ್ಕೊಳ್ಳೋಣ. ಸೊ ನಿಮಗೆ ಕರೆಕ್ಟಾಗಿ 4.3 ಯಾವಾಗ ಕಾಣಿಸುತ್ತೆ, ಈ ಸ್ಕೇಲ್ಗೆ ನಾರ್ಮಲ್ ಆಗಿ ನೀವು ರೀಡಿಂಗ್ಸ್ನ ತಗೊಂಡಾಗ. ಸೊ ಸ್ವಲ್ಪ ಮೇಲಿಂದ ನೋಡಿದಾಗ ನಿಮಗೆ ಬೇರೆ ಕಾಣಿಸುತ್ತೆ, ಎಕ್ಸಾಕ್ಟಾಗಿ ಗೊತ್ತಾಗೋದಿಲ್ಲ. ಸೊ ಈ ಕಡೆಯಿಂದ ನೋಡಿದಾಗಲೂ ಅಷ್ಟೇ, ಎಕ್ಸಾಕ್ಟ್ ಆಗಿ ನಿಮಗೆ ಸಿಗೋದಿಲ್ಲ. ಬೆಸ್ಟ್ ಎಕ್ಸಾಂಪಲ್, when you are in a journey in a car, the driver will see the speedometer to get the kilometer per hour. Okay, to get the speed, he observes the speedometer. For example, it is 60 kilometer per hour, and the person sitting beside the driver will observe the speedometer, and he may observe 61 kilometer per hour, or like 65 kilometer per hour, like that. So always we need to take the readings normal to the instrument. So this is parallax error. So next, yeah, parallax error between pointer and scale. So if we have, actually this is the direct measurement we are taking through the scale. Here he has given parallax error between pointer and scale. When we have pointer and scale arrangement, okay, when we give the input, the pointer will deflect and it shows the output. So we need to take the readings by pointer and scale. If we take the readings normally, okay, so we will get the correct readings. Okay, that is about the pointer and scale. Pointer and scale arrangement in measuring instruments. So next, observer's skill or human skill. So human skill plays an important role. Again, it is common in beginners. We need to take the readings correctly. Okay, and the observer's mental and physical condition should be good. So these are all comes under human skills. Next, errors from environmental variations. We already discussed in detail in systematic errors. So environmental variations means it may be changes in temperature, humidity, pressure, okay, velocity, etc. Air velocity, like that, etc. So when the temperature increases or decreases, so the metals present in the measuring instruments may change their dimensions. When the dimensions of the elements change, obviously we get wrong results. Okay, it won't be accurate. So this is about random or accidental errors. Next, illegitimate error. So these errors include mistakes which can be eliminated through careful exercise and repetition of the measurement. Okay, so mistakes, computational and chaotic errors comes under illegitimate errors. When we repeat the measurements, okay, 3 to 4 times and take the average, we get the accurate results. So mistakes, when we do the mistakes, okay, it comes under illegitimate error. And computational means calculation errors, and chaotic means in confusion whether we need to take that reading or this reading, whether this is the procedure or not. So what is the procedure? When we follow this step by step procedure to take the measurements, we won't get confused. So we should not confuse while taking the measurements. So chaotic error means it is nothing but confusions while taking the measurements. So this chaotic error also comes under illegitimate error. So mistakes can be reduced by the repetition of the measurement, and while calculations we need to take care of the formulas, units. Okay, when we do the calculations correctly, we will get the good results. And chaotic error is nothing but the confusions. Okay, we should not confuse while taking measurements. So this is about illegitimate error. So the last topic, the factors in selection of measuring instruments. So before purchasing any type of measuring instrument, some factors to be considered in the selection of measuring instruments. So the first comes accuracy. So accuracy expected from the instrument. Okay, how accurate it should be. So in industries, they purchase very accurate instruments for quality checking and all, like that. In industries, they maintain secondary standards, tertiary standards, which are very accurate. And when we consider the instruments in our laboratories, in our colleges, we use working standards because those those instruments are used by the students, and those students are the beginners. Okay, so what they do, they learn how to take the measurements by using that instrument. When we compare working standards and tertiary standards and primary and secondary standards, the accuracy decreases, right? The primary standards or master standards, and when we compare up primary standards and secondary standards will have less accuracy as compared to primary standards. So like that. So when the accuracy is very important, so we need to take very accurate instruments. So next, the time of taking final data required for the measurement, whether when we give the input, so how long the instrument will give the output, whether we need the output immediately, like that. The time of taking final data required for the measurement. The next comes the cost of measuring instrument. Okay, we need to consider the cost. Okay, so next, the type of data display, that is indicating, recording, photograph. Indicating means like digital, it will give the just numbers like calculators, weighing balance. Okay, nowadays we are using digital indicating measuring instruments. We have digital vernier calipers, micrometers, okay, recording. Whether we can record, whether there is a need of recording the output, we need to consider that also. Whether the instrument will give the photograph. Okay. See, for example, when we take hygrograph. So in hygrograph is used to measure the humidity. So it will record with the help of hygrograph. The stylus will be there. The stylus will record the humidity. Okay. So next, the measurement quantity to be measured has constant value or it is a time variant. When you are giving the input to the measurement system, whether it has constant value or it is a time variant, whether the parameters you are going to measure is vary, whether it varies with time or it has constant value. So even we need to consider this before selecting the measuring instrument, whether the variation is linear, parabolic, or of some other type. Okay. So these are the parameters, or these are the factors we need to consider before selecting any measuring instrument. So now MCQ questions, multiple choice questions of session 6. Which of the following can't fall under controllable errors? Which type of errors we cannot control? Calibration errors, environmental errors, avoidable errors, random errors. Which type of errors we cannot control? By doing calibration error will be, it won't appear. Okay, we can maintain the instrument. When we maintain the instrument under good ambient conditions, so good environmental conditions, the environmental errors will go off. Next, we have avoidable errors. Okay, random errors. So the random errors is the type of error which we cannot control random errors? The answer is option 4. Next question. Random errors in a measurement system are due to use of uncalibrated system, poor calibrating practices, unpredictable effects, environmental changes. Use of uncalibrated system, poor calibrating practices, environmental changes, or due to what? Whether we can predict this random error? It may be any type of error, okay? So it is unpredictable effect. So random errors in measurement system are due to unpredictable effects. So the answer is option 3. Next, in a measurement system, there will be only random errors, there will be only systematic errors, both, neither of the error will be there. We cannot decide whether the error is there or not. Neither of the error will be there. There will be always some type of error. Okay, there will be random error. There will be only random errors. There will be only systematic errors. Both. In a measurement system, both random errors and systematic errors may appear. The option is 3. Answer is option 3. Next, random error is also known as accidental error, fixed error, systematic error, illegitimate error. So systematic error is also known as fixed error, right? So option 2 is gone, option 3 is gone. Illegitimate error is a type of error. Okay, so the remaining option is 1. The answer is option 1, accidental error. So the random error is also known as accidental error. Next, errors that occur randomly and of unknown magnitude are called random error. The answer is option 1. Okay, chaotic error comes under illegitimate error. Systematic error will have known magnitude. The magnitude is fixed. And the remaining is random error. See, the random error occurs randomly and of unknown magnitude. The magnitude may change. Okay, the magnitude may change and it is unpredictable. Thank you.